And so today we will see the next part of transform Superstep. So we will start with the feature engineering. Feature engineering is the core technique to determine the important data characteristics in the data lake to ensure that we get the correct treatment through the steps of processing. So feature engineering means we have to basically classify our data based on certain features. So there are two different techniques. One is binning and another one is averaging. So two different techniques are used. Binning means we are creating bins. Suppose this is the bin for 0 to 5. This is the bin for 6 to 10. In this way, we have to classify the items whose value lies between 0 to 5, and the other values which lies between 6 to 10 will be classified into another bin. So this technique is used to reduce the complexity of data set to enable the data scientist to evaluate the data with an organized grouping technique. It's good for continuous data, where continuous data with different values, it can be grouped into different classes. Averaging is the use. It enables to reduce the amount of records which is required to create a report. So we can average out the value and we can create the data set. Hypothesis testing. Hypothesis testing is the process by which statistical data used to check if the hypothesis is true by using data. So based on the hypothetical testing, data scientists choose to accept or reject a hypothesis. First, they develop a hypothesis and then they try to check based on the facts whether the hypothesis is correct or not. So if the hypothesis is found to be correct based on the event that occurs, so we can find out whether the hypothesis is true or false. So check whether the event is important occurrence or just happenstance. Hypothesis testing is necessary. So t-test. T-test is a popular statistical test to make inferences about single means or inferences about two means or variables to check if two groups means are statistically different from each other, where n is less than 30 and standard deviation is unknown. So for a data set, if the standard deviation is not known and the data set has less than 30 elements, then we can perform the t-test and we can find out the relevance. Chi-square test. Chi-square test or squared x-square test is used to examine if two distribution of categorical variables are significantly different from each other. Like if we are given parameters, so we can identify that the two different parameters, how it is affecting a particular event. Overfitting and underfitting. Overfitting and underfitting are major problems when data scientists retrieve data insights from the data set they are investigating. Overfitting is when data scientists generate a model to fit a training set perfectly but does not generalize well against the unknown future real world data set. If it means that when we have 100 data set, so 80% of the data set is kept for training and 20% is kept for, say, testing. So what we are doing, we are creating a model in such a manner that this particular model is, we are trying to fit it to 80% of the data, and then we are testing it with the remaining 20% of the data. But if suppose some new data arrives or we have certain outliers, so this particular model is not able to classify the data correctly. So the solution works only for specific data set, but it does not work for the general data set. So this problem is known as overfitting or underfitting. Polynomial features extraction can use a chain of polynomial formulas to create a hyperplane that will subdivide any dataset into correct cluster or groups. The higher the polynomial complexity, the more precise the results that can be achieved. So basically, the data will be classified into planes, and all the data set that is appearing in a particular plane that can be classified into groups. Common data fitting issues. So these higher order polynomial formulas are however more prone to overfitting, while lower order formulas are more likely to underfit. So there is a delicate balance between two extremes. So a data scientist should be able to create the perfect balance between the data. Precision recall. Precision recall is useful measure for successfully predicting when classes are extremely imbalanced. So in information retrieval, precision is the measure of result relevance. Recall is the measure of how many truly relevant results are returned. Precision recall curve shows the trade-off between precision and recall of different thresholds. A high area under the curve represents both high recall and high precision. So that means if the area under the curve is greater, it means the recall, precision and recall both are high. When high precision relates to low false positive rate, and high recall relates to low false negative rates. High score for both shows that the classifier is returning accurate results. High precision as well as returning a majority of all positive results, that is high recall. So high precision and high recall can be achieved if the area under the curve is good. Sensitivity and specificity. It is the statistical measure of the performance of a binary classification test, also known in statistics as classification function. Sensitivity, also called the positive rate or the recall or probability of detection, measures the proportion of positives that are correctly identified as such. Example, the percentage of sick people who are correctly identified as having a specific condition. F measure. F1 score is the measure that combines precision and recall in harmonic mean of precision and recall. Receiver operating characteristic analysis curve. A receiver operating characteristic analysis curve is a graphical plot that illustrates the diagnostic ability of a binary classifier system as its discrimination threshold is varied. The ROC curve plots the true positive rate, that is TPR, against the false positive rate at various threshold settings. The true positive rates are also known as the sensitivity, recall or probability of detection. Cross-validation test. Cross-validation is a model validation technique for evaluating how the results of a statistical analysis will generalize to an independent data set. It is mostly used in setting where goal is the prediction. Knowing how to calculate a test such as this enables you to validate the application of your model on real world, that is independent data sets. So the cross-validation testing can be performed. So with this, we have come to end of our chapter. Thank you.